Hello, tech explorers. Today, we're diving into the fascinating world of multi-tenant ML platforms. What are multi-tenant ML platforms? Imagine a huge apartment building where different families live separately but share common facilities like elevators and parking. Similarly, multi-tenant ML platforms let different teams or companies use the same infrastructure while keeping their data and models completely separate. Now, let's look at our real-world analogy section. Think of a shopping mall where different stores operate independently but share electricity, security, and maintenance services. Here are the best practices. Isolation. Keep each tenant's data completely separate. Resource quotas. Set limits so one tenant doesn't use all resources. Security. Strong authentication and authorization. Monitoring. Track usage per tenant for billing and optimization. Moving to our implementation strategy section. Here we have a code example showing tenant isolation. Now, let's look at the pro tip section. Use containerization with Docker and Kubernetes to ensure perfect isolation between tenants. This is how we build systems that serve multiple customers safely and efficiently. Welcome back. Now we're tackling the incredible challenge of scaling MLOps for hundreds of models. The challenge section tells us that managing hundreds of ML models is like conducting a massive orchestra where every musician needs to play in perfect harmony. Each model has different requirements, schedules, and performance needs. Let's explore our analogy. Think of it like managing a huge restaurant chain where each location has different menus, but you need consistent quality and efficient operations everywhere. Here are our scaling strategies. Microservices architecture. Each model as independent service. Container orchestration. Use Kubernetes for auto-scaling. Pipeline templates, standardized workflows. Automated testing, CI/CD, for every model. Moving to our pipeline architecture section. Here we have code showing scalable pipeline management. Now, let's look at the remember section. Use async await and thread pools to train multiple models simultaneously. This is how we scale from one model to hundreds without losing our minds. Great to have you back. Let's explore deploying ensemble models. What is an ensemble model? An ensemble model is like having a panel of expert judges where each judge gives their opinion, and the final decision is made by combining all their votes. This usually gives more accurate and reliable results. Here's our real-world example. When doctors get a second opinion for difficult cases, or when judges score in competitions, multiple perspectives lead to better decisions. Our deployment strategies include parallel processing, run all models simultaneously, load balancing, distribute requests efficiently, fallback mechanisms, handle individual model failures, weighted voting, some models count more than others. Moving to our production implementation section. Here we see code for ensemble model management. Now, let's look at the pro tip section. Always have fallback plans when individual models in your ensemble fail. This is how we make our AI systems more reliable and accurate. Welcome back, tech adventurers. Today we're solving managing model dependencies. The dependency challenge section explains that managing model dependencies is like organizing a huge recipe collection where each dish needs specific ingredients and cooking tools. If ingredients conflict or tools break, your entire kitchen stops working. Let's check our analogy. Think of it like a smartphone where each app needs different system resources, but they all need to work together without conflicts or crashes. Our best practices are containerization, each model in its own container. Version pinning, lock specific library versions. Virtual environments, isolated Python environments. Dependency scanning, check for conflicts early. Moving to our implementation example section. Here we have a Docker file for model deployment. Now, let's look at the remember section. Use Docker multi-stage builds to keep your containers small and secure. This is how we keep our ML systems stable and conflict-free. Hello again. Let's dive into online learning in production. What is online learning? Online learning is like a student who keeps studying and improving even during the exam. Instead of learning everything beforehand, the model continuously learns from new data as it arrives in real time. Here's our perfect analogy. a GPS navigation system that learns about new traffic patterns and road closures in real time to give you better routes. Our key components include streaming data, continuous data flow, incremental updates, small, frequent model updates, concept drift detection, detect when patterns change, model validation, ensure quality during updates. Moving to our implementation pattern section. Here we see code for online learning models. Now, let's look at the pro tip section. Always validate your model's performance continuously to detect when it starts making bad predictions. This is how we build AI that gets smarter every second. Welcome back. Now we're building a complete CI/CD pipeline for ML models. What is CI/CD for ML? CI/CD for ML is like having a super efficient factory assembly line that automatically tests, packages, and delivers your ML models. Every time you make changes, the pipeline ensures everything works perfectly before shipping to customers. Let's explore our analogy. Think of it like a quality control system in a car factory that tests every component before the car reaches the customer, but for ML models. Our pipeline stages are code integration, merge, and test code changes. Model training, automated training on new data. Model validation, performance and quality checks. Deployment, automated rollout to production. Moving to our pipeline configuration section. Here we have a GitHub Actions workflow example. Now, let's look at the Remember section. Automate everything, from testing to deployment. Manual steps lead to errors. This is how we deliver perfect ML models automatically. Hello, Tech Explorers. Let's learn about model monitoring and drift detection. Why monitor ML models? Model monitoring is like having a health checkup for your ML models. Just like humans need regular checkups to stay healthy, ML models need constant monitoring to ensure they're performing well and haven't drifted from their original training. Here's our perfect example. A weather forecasting system that needs to detect when climate patterns change so it can update its predictions accordingly. What to monitor includes data drift, input data changing over time, concept drift, relationships in data changing, performance metrics, accuracy, precision, recall, system metrics, latency, throughput, errors. Moving to our drift detection implementation section. Here we see code for statistical drift detection. Now, let's look at the pro tip section. Set up automated alerts when drift is detected. Don't wait for your model to fail completely. This is how we keep our AI healthy and reliable. Great to see you again. Today we're building feature store design and implementation. What is a feature store? A feature store is like a well-organized supermarket for ML features. Instead of each ML team creating their own features from scratch, they can shop for ready-made, high-quality features that others have already created and tested. Let's check our analogy. Think of it like a shared library where different departments can borrow books instead of everyone buying their own copies. It's efficient and ensures consistency. Our key benefits are reusability, share features across teams. Consistency, same feature definitions everywhere. Freshness, real-time and batch feature serving. Discovery, easy to find and understand features. Moving to our feature store architecture section. Here we have code showing feature store implementation. Now, let's look at the Remember section. Document your features well. Future you and your colleagues will thank you. This is how we share and reuse ML features efficiently. Welcome back. Let's explore model retraining and automated deployment. Why automate retraining? Automated model retraining is like having a personal trainer who automatically adjusts your workout routine based on your progress and goals. As new data comes in and patterns change, your model needs to exercise with fresh data to stay fit. Here's our real-world example. A recommendation system that learns your changing preferences. If you suddenly start liking jazz music, it should adapt automatically. Our retraining triggers include performance decay, accuracy drops below threshold, data drift, input patterns change significantly, time-based, regular scheduled retraining, volume-based, after collecting enough new data. Moving to our automated pipeline section. Here we see code for automated retraining logic. Now, let's look at the pro tip section. Always validate your retrained model before deploying. New data doesn't always mean better performance. This is how we keep our models fresh and accurate. Hello again, tech adventurers. Today we're mastering experiment tracking and model registry. Why track experiments? Experiment tracking is like keeping a detailed lab notebook where every scientist records their experiments, results, and observations. Without it, you'd forget what worked, what didn't, and how to reproduce your best results. Let's explore our analogy. Think of it like a chef's recipe book where they note down every ingredient change, cooking time adjustment, and how each variation tasted, so they can recreate the perfect dish. What to track includes parameters, learning rate, batch size, etc. Metrics, accuracy, loss, validation scores. Artifacts, model files, plots, logs. Environment, code version, dependencies. Moving to our tracking implementation section. Here we have MLflow tracking code. Now, let's look at the remember section. Tag your experiments with meaningful names and descriptions. Experiment 1 won't help you later. This is how we organize our ML experiments like true scientists.